Today 3715 sum of perfect square ancestors. It's gonna be some bullshit new problem, but whatever. You are given an integer n and undirected rooted tree with nodes. So we got some edges, integer array nums. Okay, so nodes have values such that product, what the hell? Sum of all ti values for no, what? Who comes up with this? Oh my days. Okay. That is ridiculous. Okay. 3 is 10 to 5. Oh. Okay, let's see. Let's say we have some ancestors, right? Well, when does it make up a perfect square? If each divisor in this number plus occurrence of divisors in here is, so if combined sum of visitor or divisors of this number and this number is even for all divisors. And how to do that fast? Great question. So let's say we think backwards. So instead of for a vertex, for a vertex checking all his ancestors, how about for a given node count how many nodes in its subtree make a perfect square with it? How can we do that? Okay, how big are the numbers? 10 to 5. That's great, because what I think, but there are gonna be a lot of primes. Okay, we do prime factorization of each number, and if it has even number of divisors, then we just want, or if not, so we don't care about the prime factor divisors that occur however many even times. We only care about the odd ones, and for the odd ones we also need them to occur odd many times, right? So that's way too many prime factors to my liking. It could be, I guess, at most, if everything is a 2, then you got n times n minus 1 divided by 2, which is 5 times 10 to 9 or something like that. There is a bunch of hints, but we don't care about those. I'm thinking. Let's say I want to count how many trees. So okay, we are at the point where, so for vertex V we want to count nodes in a sub 3 with odd number of divisors which have same odd counts which have same divisors, prime divisors with odd count. That's what we want to do. Okay, well, how many could there possibly be? 2 times 3 times 5 times whatever. So let's see. Return 2 times 3 times 5 times 7 times 9. No, 11, 13, 17, 19, 23, 29, 31, 5, 6, 37, 41. I don't think that's, maybe, I don't know, 43. Who cares? Let's see. Bool prime int x. So let's see how many primes can there actually be. Return true. And now int x is 1 while x is more than or equal to 1. 1, 2, 3, 4, 5. While not prime d plus plus x times equals d return x. Let's see, should work. And I want to do if x times d over 100,000 break. Okay, otherwise we will solve this. Okay, interesting. Really? 7 primes only? Okay. Okay, that's good. So what this essentially means that each number can have at most 7 odd prime numbers, odd times occurring different prime numbers, which is awesome because we just store the vectors of them and check if there is and count such vectors, so we can have map set or map vector, right? And then just count them, and I guess that's it. But we also have to check if I think that's enough. Okay, but that's gonna take way too much memory, so because wait, no, you would have at most n times 7, so that's okay. Okay, this could work. So that's okay, so that's for some analysis. Now what we need to do? And first we get all prime numbers. Up to square root of 10 to 5, which is like 10 to 3, let's say. So all prime numbers up to 1000. And then okay, so vector int primes get primes up to 1000. Primes actually I mean, if I could override the constructor somehow, then I could skip generating this every time, but I guess that don't matter. So get primes int max. So primes, and then is prime of max. Is prime all are true, no, all are false, or all are true, I guess. Then we want to do if not is prime continue, else pushback I is prime I is 1 for int j I times I j max j plus is prime j1. Okay, so now that's a CV, and then we need them divisors. Okay, so I need to make an adjacency matrix. Ajax push back y, aj y push back x. Great. Can have at most. Okay, so let's two numbers make up a square product of two numbers is a square number if for each of their divisors the combined divisor count for both numbers is even. Therefore, the since even plus even equals even, we only need to check if the divisors occurring odd number of times match for both numbers. There can be at most 7 unique divisors occurring odd one number of times, since num_i and 2 times 3 times 5 times 7 times 11 equals 83. Really? 4 shouldn't be there, so that's 20k, and 9 shouldn't be there, but then we get 13 and 17. I think that should be enough. 2 times 3 times 5 times 7 times 11 times 13 times 17, and who cares, that's unreachable. Okay, so actually at most 6 unique divisors, since this is 30,030. Great. Okay. Okay, so, but wait. Yeah. Okay, so we make a graph and then we do vector, odd divisors for each of them. The edges are 0 index or 1 index. Okay, 0 index, great to see. So we run DFS from node 0. Probably I need visit it, but this will get me, okay, so let's do that in private. So void DFS int vertex, vector int visited, vector int odd divisors, vector int primes. This is const because we don't change that. So first of all, this v is 1, and I also forgot to pass vector. This is also const because we won't change it, which is the adjacency list. If u does, okay, if not receive, then DFS u archvis odd div source primes. After we visit, we wanna go, so for int I is I is under prime size, and primes I is smaller than or equal to, well, the number itself could be a prime technically, so my max in fact should be this. Okay, and then so prime xi is smaller than num xi, so I also have to pass nums. Oh my days, why am I even doing it here? So unnecessary. I can just call DFS here and maybe. Okay, and then maybe I can just put this code here. So okay. While this happens, okay, so while let's see, int x num xi, while x percentage primes I z. Wait, so if it's divisible by that, okay, no, let's just do this. While this, then odd divisors of W push back primes I, and then X primes I, and that's it. Okay, so now let's return 0. Let's see. What the hell? DFSU. Voiding. Boom. Okay. What's nums? Nums declared. Okay. What the hell? Where? Okay. So okay, that were, oh, what the hell? Well, for one, well, here I don't really understand that why. And what about this? Well, you run here, so prime size, and while primes is, oh my god. Okay. So if we are at we have odd number of times odd divisors of a W, okay, I guess. So this one has just 1, 2, this has 3 2s, and this has 1, 2. That's fair. Okay. Okay, and here only 2 got it, so this is 3 3. Okay, so those are your signatures right there, right there, right there, right there, right there. Okay, let's see. We do this first, right? Then we keep like a map, set map. I guess we just need a set. No, we need map of this. Let's call this like fingerprint And so I technically don't need this, so I get my fingerprint. So odds push back. Okay, and so after we get the odds, we want to compare to, okay, so let's call this ancestor fingerprints, ancestor odds. Okay, and then else plus equals ancestor odds. Let's have answer here. Okay, let's do that. And then, okay, so well, we put it there. So ancestor odds plus, and then ancestor odds minus. Okay, map vector int long, boom, should work. Okay, ancestor odds, this wants to be a reference, and then probably we need it, so, and then actually we don't need all this, and I don't need to declare it here because I just declare it here, and that's it. Great. Okay, that was pretty easy, I think. If it works, maybe it's slow, I don't know, looks like it's slow. Oh, TLE for a few cases. Oh, because I cannot do a CV. Okay, if I use this test case, how long does it take? Shouldn't really take that long. 430 milliseconds. That's a lot. I mean, map is slow. That's true, but I don't know how I could speed this up, because I would have to somehow like remove one log factor, but I'm not sure I can do that, and I really don't want to do hashing of this. I mean, maybe if I do Python it will. 2 test cases don't pass. Okay. Well, that needs to be sped up even. Somehow. Okay, if I take it out, if I take this whole thing, then I have to pass million parameters, but let's say visited adjacency, ancestor odds, answer, primes, nums. Okay, everything needs to be passed in, but whatever. Private. So let's see what we need. Visited adjacency, ancestor odds, vector. Vector int long ancestor odds. We pass that as a map. Okay, and then we need ans primes nums. So long ans vector int primes vector int nums, and then we need to pass it all here. Okay, I will try it this way, and then I will not do this in the FS if that will help anything. I'm not sure, but whatever, I guess. So we pass in this ancestor odds, ans primes nums. Let's call it. See if it takes any. Okay, it takes like 20% less, maybe 25. Okay, TLE in one test case. Okay, well, I guess I tried. Let's do vector odds, and then do const, and then do odds w, and then do odds w here. Okay, so let's see, redefinition of odds. Okay, that's faster. Okay. Still TLE in one test case? Are you kidding? Ridiculous, man. Ridiculous. How long doesn't that test case take? I hate when Leetcode gives you time limit for combined test cases. Who did that? Who did that? And this seems like a straight line. Ridiculous, man. Ridiculous. I really don't want to do it in Python, but I feel like I will have to. Okay. Primes is prime 1 times primes. Okay. Okay, so now we got the primes. Now we need to build the arch. For x, y. Okay, and then we need to count the primes, so okay. X moves v for I0 while I is primes is len primes and primes I x. Then we want to do while x percentage primes I is 0. Then we want to do x divide primes I. Okay, I guess that's fair. So we got the odds, and now we need the like a map. So map of tuples maybe. Odds w equals tuple of odds w print odds w return this is prime. Output limit exceeded. Okay. Wait. Okay. Should work. Okay, so we got them tuples. Those can be hashed. So now we can ancestor odds is, let's let it be this dict, and then what we default dict int, and then we go def dfs vis, okay, vis v1, and then what we want to do, ancestor odds w for u in hv if not vis u dfs u, and then ans plus equals ancestor, okay, and then ancestor w minus equals 1, we run dfs0 and then we return ans. I hope that's it. Okay, it needs the local variable. Oh, it sucks. Okay, maybe not like that. Global ans. Ancestor od arch vis, maybe like that. This is not defined. Oh my god, bruh. This. Okay, let's do it like this. Self this, self this, self this, self this, self this, self this, self self the FSU, self that. We make this a function. Okay, we don't need to do that for primes. Okay. Runtime error. You mean self odds? Yes. Self ans where? I'm not sure this will pass even in Python. Gotta be 10 times slower. If I could just pre-compute the primes once and not every time. Okay. Probably will not pass, so there is that. If let's do it like this, so I declare a private variable, right, which is called primes, and now what we want to do, well, if primes only, we fill it if it's empty, right? Let's see. Great. Maybe they clear it every time, I don't know. It's TLE again. In one case. I'm not sure what step could be sped up more. Like, I really don't know. This is weird, dude. Maybe if I remove visited, swap it for parent, I have no clue what to even do. I could run it a million times and it still won't work. $544 and this takes 564. So I just shaved off 20 milliseconds. Oh. Still TLE, bro. How? How am I supposed to make this work? Luckily it's not midnight, so maybe this long is wrong. Maybe this should just be int. This should be int. It doesn't have to be long. Maybe unsigned int. Wait, runtime error. 50,000 is 1,000,000, and okay, let's say that's 600 times 600 is 36,000. 49's for, wait, so this passes, let's see, let's run it. Either way, this still runs only once, so, and it didn't change anything, it just allowed me to use that. So let's see what was the least we can do. Oh, 395, that's better, that's way better. But I still only run this once now. Still TLE. If they would like, okay. I don't understand this. What the hell am I doing wrong? Like, I cannot use anything other than vector. I cannot use something else other than a map. Unordered map will say it cannot hash a vector. So, yeah, it is what it is. You know, how about I throw this out and I just directly do this, right? So don't think that will work, because now we get into square root territory, which is not great. Before we was at some log, so this is gonna take a while, and we even get a wrong answer, so haha. It runs faster, so so what we do is int any is this, and if sent over 0, any 1, and then if not any, then ought be. So 1 has one such divisor, not any, and x over 1 maybe. This will TLE its n squared, and I don't know why am I even what the hell. Okay, well that's way faster. Okay, so I was barely here. Okay, that's fair. If we erase max. 605, 625. Okay. Whatever. This goes into disgusting, dude. Small to large merging. What do I do? Remove duplicates. Okay. Oh my days. That was the entire solution. You gotta be kidding, dude. You gotta be kidding. That oh my god. Okay. 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 Passing unordered map. Why couldn't I think of that? Oh my god, it ridiculous. Order it. Okay, one thing that's missing is it's W over 1. This. Well, that was way easier. Way easier. Oh my days. Are you kidding, dude? Holy. I'm so stupid. And if I do it now with prime factorization, then it's gonna be fast. How dumb. How dumb do I have to be? Prime factorization. Oh my god, dude. Intuition. When we multiply two numbers together, their product is a square number if all divisors, all prime divisors occur even a number of times. Therefore, each divisor of each number has to in total occur even a number of times. Therefore, we can ignore all even number of times occurring divisors and only have to compare two numbers, compare the two numbers products of odd number of times occurring divisors, and if they match, the product of the two original numbers will be a square number. We pre-calculate for each vertex, we pre-calculate its odd number of its product of odd number of times occurring divisors and then remove, and then we simply run a DFS having a hash map of seen ancestor products and increase answer accordingly. Of n squared n if we find prime factors and their counts. How many prime factors are there? I mean, technically I could try to do that. So for we can remove that, and then prime xi, and then prime xi. Okay, and okay, so we have that vector in this prime. If not this prime. Is prime J1. This could work too, I guess. But it will be slower. Not sure why, to be honest, but still time, even in this scenario you get TLE, so n squared of max where good question, but I think this is all FAANG since we store the product of odd number of times occurring ancestors. Okay, I'm so sick of this. That is crazy. Let's read time complexity n log n. Why is this n log n? I don't understand, but okay. I mean, that's AI, so who cares? This guy will have a good one. And squared m, where m is the largest number. You are also missing that, but wait, 3. Okay, so, okay, I made a mistake here. Damn. Okay. Interesting. Holy, what is this trash? I need to take a piece, but this has again taken 1.25 of an hour. Okay, squared nums I. I'm done for today. This is getting more ridiculous by the day, bro. Goodbye.